Hi, my name is Jose Villazon, and this is my Physics 1 Lab 5. A little bit of an introduction. The purpose of this lab is to observe how collisions work and create a computational model that models a collision. Some of the physics models and principles we'll be using in this lab is Newton's first law of motion: an object of motion stays in motion unless acted upon by an external force, and an object at rest remains at rest unless acted upon by an external force. We'll also be using the conservation of linear momentum in this lab, as you can see in that equation there, and then as we've used in the last couple labs, position update formula and a velocity update formula, and then we'll also be using the concept of elastic and inelastic collisions in this lab. And a little preview of results are the computational model pretty accurately predicted what actually happened in our experiment. This is a video of our experiment. So in our experiment, the system was the two pool balls and the surrounding was the pool table. So the initial conditions were the mass of both of the pool balls was 0.165 kilograms, and there you have their initial positions with our origin and everything, and then you also have the initial velocities, and these initial velocities are before the collision, and then these are the initial velocities after the collision. And we start at t equals 0, and then delta t progresses by 1/60. Okay, so for the code, we have so before the collision, and in both of these cases, we're going to assume that there are no external forces acting on the balls. So then all we have to do, since it will be at a constant velocity, both of these, then you just have to do position update formula and velocity update formula for both of the balls, and then how we have some visualization stuff there at the bottom. And it's the same thing again for after the collision, but just during a different time. And then this was the output of our code. As you can see, there goes one pool ball, and then it crashes into the other, and the other one starts moving. And then here's our comparison of the graphs. So the light green that says ball 1 was the graph for mass A, so this one, and as you can see, pretty accurately modeled. And then the same thing for ball 2 is this blue line, which you can see is also pretty accurately modeled. And then this one, it falls flat because then it stops moving, and this one wasn't moving initially until here, so then that's why there's the flat line there. Some possible sources of error: there could have been some friction with the table that could affect the pool balls. Also, that table has a little bit of imperfections and stuff and bumps in the table, so that could have also affected the pool balls. Air resistance was also not taken into account, so that could have messed with our model as well. So for our what if question, so what if we took into account friction and air resistance, and how would the model change as a result? If we took friction and air resistance into account, the net force would not be 0, and you would not have a constant velocity. This would be because you would have to take into account the force of friction and the force of the air resistance acting on the pool balls. So the speeds of the pool balls would be kind of slowing down a little bit in a model where they take these forces into account. If we took these forces into account, it would probably lead to a more accurate model that better predicts the collision between the pool balls. But in our case, we were assuming an elastic collision where no energy was lost to the outside forces. But in this case, if we took friction and air resistance into account, this would be an inelastic collision since it's losing energy to its surroundings. Thank you.